Hello again, everyone. So in the last video, we saw how we analyzed some Twitter data that was stored in a file, and that was some sort of a screenshot of the sample data that we have. And then we started analyzing it for two different things. We started analyzing for the people who actually sent the tweet and the people who were mentioned in a tweet. In this example here, we have McLaughlin, I believe, underscore K, and then McLaughlin, um, um, what's the word, retweeted or mentioned somebody with a handle called The Last Pirate LA. So we constructed a network from all these pairs of interaction, which was really very good. We saw a network that looked like that, and these were the pairs of the interactions. So today I want to show you something, a much shorter video, but it's really very important and a continuation of what we did. Um, Suppose now I don't want to be looking for the people who were mentioned, but I want to look at the hashtags that were available in the tweets that people mentioned or that people tweeted, like Monday motivation, for instance. Hashtags could be a great source of information. They can point at an event. They can point at a date and time. They can point at the geolocation. There are so much to explore with hashtags. You can definitely point at a person as well. So let's just get started and continue with the work that we're done here. So instead of just looking for the words that start with an at sign, why don't we just also ask else if the word that we are reading from the file, from the tweet, starts with, like that, with an S. Instead of an at sign, we just have to look for a hash, which means any word that starts with this pound sign, it will become a hashtag. So what I want to do now at this point, I actually want to do the exact same thing, except that I want to record the instead of recording the user interaction, I want to record the user hashtag of their own contributions. So anything you contribute or anything that you socialize or you make as part of your tweet will be captured, and we are going to put it here in this list as opposed to the user mentions the earlier one. So what I want to do here is basically take the user hashtag list like that, and I would like to append it by what? I still want to put a tuple in there, and this tuple should have two different components. The first component is the handle, so that would be very similar to this one here, and the second component would be the actual word, because that word now will be stored in a different list. So we're doing exactly what we did in the case above, except that this time we are, let me see, we are storing it in a different list, and this list is going to give me a pair of interactions. So if I run this like that, we would like, okay, it seems, all right. What we did here, we wanted to pass a tuple of two different components. So let's run it one more time, and it seems that I have not indented properly. It seems it's just not liking what I've indented here. So let me run this one more time. Still something is hinky here. I'm not sure what it is. It says line 13. So where is line 13 here? Line 13. I'm not sure where line 13 is. Okay. I don't know. Does it mean this one here? Let me try. Okay, well, let me do this. What I'm gonna do, I'm just gonna cut this one here and try to isolate the error and see where the error is. So let me do that like this. Okay, so it seems like we are okay. Else if like that, we want to ask if the word starts with a hashtag, and like that. And what I'm gonna do, I'm just gonna do an empty print statement just to see if this is the case, if this is the problem or not. It seems we don't have any issues. So the only issue that we actually have right now is to populate. Let's populate. So append here like that. And what we need to do is to append a tuple like that. Okay, so we're missing another one. I believe this is what we were missing. We only added two parentheses, but we actually needed three because this is the closing. This parentheses is the closing for the strip function, and this one is the closing for the tuple. As you can see, it's highlighted here, and that last one here is the closing for the append. So we definitely needed three different parentheses. So I believe we are good so far. We're not gonna get this error anymore, I don't believe. And well, the word append is not a pen. Yeah, so we are not gonna get this error anymore. This is really great. So we certainly did not get the error the error that we were working with. But let me also get rid of this print statement here because it's causing us to see all these blank lines. So I'm just gonna do that one more time and I'm gonna run it. And sure enough, now I want to see if I want to print the actual list of hashtags here, and I want to test it. When I mean the actual list of hashtags, I mean the actual list of users and their hashtags. So I would like to measure the length and see if it's an empty one or not. And we actually have 510 pairs. And let me do print the first element of the user hashtag like that. And it is showing me something here. Let me do the second element, which is at index 1. And Gale Grassroots, we don't know what that means, but clearly when we analyze the network when we construct a network from these pairs of interaction, the person and their hashtags, then we can actually construct the network. And this network can be analyzed, and then we can take a look at the most important hashtags. And if something happens to be important, like if this becomes important in the analysis, then we have to figure out what that means. All right, so now I want to construct a network from these users and hashtags. How do I do this? Well, to construct a network, we're gonna go back to our network class here like that. And we are going to create a network, right? Like that. And this network takes three different parameters. The name, so I'm gonna call this user hashtag socialization or socializing, it doesn't matter. And I would like to add a type for the network. I will leave that type empty for the time being. And I'm going to add the empty dictionary here, because all we care about is just to get the user hashtag graph. We need an empty one so we can actually populate. And let me make a few more cells so we can work with this here, and then we see our work here, and then we separate it from the user interaction. We just want to put that user interaction behind us for the time being. This belongs to the previous video. So if I run this here, then I've gotten an empty network object. And how do I know it's empty? Is because we did not populate it by anything. We basically constructed an empty dictionary to make the network. So now what do we need to do is to invoke the info here and see what's happening. And it's basically telling me the name and the number of nodes is 0, and does not yet have a type. I will tell you what that type will be later on. For the time being, what I'm more interested in right now is to actually add edges from that list of user hashtag. That's what I'm interested in. Because if I do that, then I will very likely to have a network constructed. Then let's try. And sure enough, this network here is actually returning that dictionary with a list of users and their hashtags. Let me see here. The reason why wait just a minute. Why are we having some well, I think the network is kind of generating edges from both ends. So it's basically making what we actually need in that network is to make the users are one side, and then the actual hashtags is the other side. But clearly the network here is making it bidirectional, because that's how this function is currently implemented. So we do it from x to y, and then also from y to x. But in theory, this network should not be constructed this way, and I will tell you that's the reason why I did not give it a type here. This is for the time being. This is an undirected network. That's all there is. But what we need, actually, what we're gonna do, maybe you can just create a user hashtag dictionary like that, and I will tell you why we need this. This user hashtag dictionary can be also passed to a network object, a network X object, so we can visualize it like that. And then we are going to construct a graph, and we're gonna pass, and this is gonna give us a network X user hashtag graph. And this name here is basically arbitrary. There's nothing special about the name other than that it tells us what's inside there. That's how I encoded it, but you can choose any name you want. So if I do that, then I constructed a network here, and I am going to invoke the info function that belongs to network X now, because now we're going to be working with an object from network X like that. And I'm going to pass this network here. So as you can see, it's given me some information, and so far we don't really care about the name, but if you really care about the name, it's not a problem. We can pass the name here, I believe, like that. And using a parameter called name, it's an optional parameter. If you don't pass it, nothing happens. So we can call this user hashtag network. Okay. Right. It seems we might actually. It doesn't matter, let's just not worry about the name of the graph for the time being. It's irrelevant. I just wanted to make sure that we actually give it a name here, but it's not important at this point. But what's important now is the number of nodes and number of edges, because now we know that this network is fully populated. So what are we going to do with this? Well, now we know how to use network X to draw. Let's just draw it and see what's happening. Network X has a draw function, and this draw function takes a network object or a graph object, and it takes a whole bunch of other parameters. Do we want to see it with labels? With labels, for the time being, let's say no, false is not true, that I want to see it with labels. And I want the color, the node color, to be red, and this is good enough. And this is gonna take some time. Well, it didn't take some time. If I play with the node size and all that stuff, Let me also give it some labels maybe. So that will be true. You're going to see a lot of hashtags here showing up. Now this might, okay, with labels, yes. So labels has to be capital in plural. And this will, okay. Well, these are a lot of warning, but the warnings are not important. If we actually run it one more time, it's going to get rid of these warnings here. And then we're going to see an interesting network that is just fully stuffed with all the hashtags and handles. Yeah, clearly here you can see some hashtagging and can also see a handle as well. So we understand now that this network is supposed to be is fully populated by the data that we intended to do, and that's how we can construct a network. Now I want to give you the type of the network that I intended to construct. This network here, because it takes two different types of, um, of nodes. One of them is a handle or the user, and the other one on the other side is the actual hashtag. So since we're only constructing, and again, ideally, if we are constructing a network from one side into another without connecting each side to each element from each element from the same side together. Like if I connect users with other users, then that breaks the type of network that I'm trying to tell you. This network is a very special network, and it's actually called a bipartite network. So this type of network here that we wanted to create, we called it directed, but it's actually where is the name here? So this should be a bipartite network. Okay, bipartite networks or bipartite graphs are very useful graphs. They have many interesting problems to solve, and they have a lot to offer in terms of network science. So this is what I wanted to show you today, and I wanted to show you just a small piece of code here that we added to the lovely work that we've done last time. Clearly, we've done a lot, and just working with the hashtags as a new dimension to our analysis, we started to construct a new type of network, and we started to see this kind of network. And remember that this is now called a bipartite type of network because it has two different types of nodes. In this case, there is a type of user handles and another type of hashtags. As you can see, the hash pound here, the hash sign, and also the handles. And this network, we can actually ask if it is bipartite or not. Not that I remember the syntax handy in my mind, but we can do some research next time, and then I will show you how we can test if this network is a bipartite or not using NetworkX. Okay, for the time being, I think this is good. I'm gonna leave this short and sweet, and as always, if you have any questions, write me a comment or send me an email, and thanks again for watching.